Welcome back to part 2 of the lecture on nesting functions and decorators. These two subjects, they go hand in hand because we typically only use nested functions for decorators. So as a quick review, when you're defining a new function, it's a statement that assigns a function to a variable, and you can actually have within a function, a declaration of a function. It creates a new function each time it's called, and that function will reference the namespace through the environment. The environment includes a namespace of the parent function that it was called from. Okay, so we're going to talk about some decorators, what decorators are, how we use them, and how we can write code that does these things that we want to do. Okay, so decorators. Before a function and as well as a class, when you define functions and classes, you can put an @ symbol and then some code here, and then you can define your function. Okay? And what this does basically is it runs something that's similar to this. First it says, let's create the function. Okay? And then it says, we're going to assign fn to be that decorator, whatever that was, the result of the decorator called with the function. Okay, and this is probably, if you're not used to seeing functions being passed as parameter to other functions, you're going to get used to it now. Okay, and this is basically what happens. There's a small difference in that the function is not set to the variable until after the decorators are called. So if your decorator tries to access the global and tries to find the function that is decorating, it's not going to find it. Okay, all right. So you can also nest decorators by stacking them. So if we had A and we had B and then we had def fn, that's basically going to say fn is equal to A called with the result of B called with the result of that function we just created. That's basically what it's going to do. All right, let's go over why we use decorators. And this is kind of a topic that you might have heard of called aspect-oriented programming. Okay, I'm not going to speak much on what aspect-oriented programming is. It's kind of a minor topic. It's not really very useful, but it's something to know about, something we talked a lot about like about 10 years ago. It's a really popular topic. Okay, so decorators, why? Typically, we want to modify the function somehow. Okay, and I'll show you how we can modify the function in one way. Another reason why we do it is we want to record the function. We want to store it somewhere that we can access it later. Okay, typically with a web service, we want to record which functions match to which URLs. Okay, and so you'll see decorators used in many of the web environments, the web platforms. Okay, another reason why is we want to wrap the function. Okay, and this one is the case where you generally want to create a function that will wrap the function and you return that as the decorator. So you're basically substituting the function with the new function. We'll go over some cases there. And the reason why you wrap is you want to modify the parameters, or you might want to change behavior before, after behavior. So before the code runs, do this. After the code runs, do that. And you may want to modify the result. Okay, so let's look at some examples here. First, we're going to try to modify the function. Okay, and this is a very trivial example. It's not something you typically see. I have written code like this in the past for various reasons. So here's a decorator. We're going to define a function. We're going to call it green, and it's going to accept a function. And what we're going to do is we're going to take that function and we're going to set the green attribute on that function to be true, because this is a green function. Okay, and then we're going to return the function. Okay, you might not be familiar with this. We're going to go a lot deeper into this when we go over programming classes and attributes and methods and stuff like that. But basically each object in Python has its own namespace, and so this is saying I'm looking inside the function object for the green variable and I'm assigning that to true. That's basically what it's doing. Okay, in order to use this, we're going to say @green, and we're going to define a simple function, add, which is going to take A and B, and it's going to return A plus B. Okay, and so when we go to look at add, we can do add.green to look at the green variable in the add namespace, And this is going to tell you that indeed this is a green function. Okay, so this is a pattern that we'll see typically with functions. If you're modifying a function, it's very difficult to modify the code itself in Python. Other languages like Lisp allow you to freely interact with the code and change it as you want to, but in Python that's not very easy to do. So typically we're just modifying attributes around the function. Okay, so that is how you would modify a function. Let's say you wanted to record the function somewhere. So we want to remember, for some weird reason, the last function that we've defined, right? And so we're going to define a remember function, a remember decorator, which all decorators accept the function. And then we are going to say global last fn so that we can assign to it. And then we'll return that function. Okay, and so let's use this decorator. So we do @remember def add a comma b, and we're going to return a comma b, a plus b. All right, and so now we can do last fn 1 comma 2, and that should give you 3. Okay, and you could try using remember on different functions and see how it works. Okay, that's remembering stuff. Typically when you remember things, you want to store it in some kind of namespace, like an object somewhere, or maybe a dictionary, but we're not quite there yet in Python. I haven't quite covered those concepts yet, so we're just going to look at this and smile and say that's awesome. I encourage you, as I'm going through this lecture, to take the time to understand what this code does. Run it through an interpreter, run it through the interactive mode. And if you have any questions about this code, please comment below. I would love to answer your questions. All right, I'm begging you, please. All right, next function, wrapping. So we want to wrap. So we are going to wrap the function, in this case, to modify the arguments. Okay, so we are going to define a decorator that says it takes 2 floats, 2 floats. Okay, and 2 floats is going to take a function, and it's going to return a new function that will accept the parameters, modify them, and then call the actual function. So we're going to call that a wrapper. So the wrapper itself is going to take 2 parameters. It's going to change these to be floats. So b equals float b and a equals float a. And then we're going to call the original function, and then we're going to return the result of that. So let's do this. Return like that. And then the decorator has to return a function. It's not going to return the original function. It's going to return a new function. Okay? And then we're going to use this like this, 2 floats. And we're going to say def add a comma b, return a plus b. And when we call it, let's say we call it with integers, 1 and 2, and that should give us a float back 3.0 because it converted the 2 integers, the 2 parameters, to floats. Let's look in detail about how this works. Okay, so we're going to pull out our sticky notes. So when we call 2 floats as part of the decorator, it's going to pass in the add function. So let's go ahead and look at what that looks like. So it's going to create a new namespace, a local namespace. It's going to say fn is equal to this add function. That's not quite defined yet. Okay, and then we're going to create a new wrapper. So we're going to have wrapper equals this new function that we've just defined. Okay, all right, and then we're going to return that wrapper. So this is the result. So this is the return result. So we are going to keep this around because the wrapper itself wants to remember this thing. So when the wrapper is called, here we're actually calling the wrapper, not the add function, but the wrapper. Okay, and so when we call the wrapper, we create a new namespace. Okay, and we have a is equal to 1, b is equal to 2. The first line says a is float of a, so now it's 1.0. b is float of b, so now it's 2.0. We return a plus b. So we take 1.0 plus 2.0, return that value. Wait, no we don't. We return fn of a plus b. So we're going to call the original add function with the 1.0 and the 2.0. It's going to add those to 3, and that's the return value. So that's what's going on here. Every time it's called, it's going to create a new namespace with the 2 parameters you passed in, and then it's going to call the original function that's preserved because we have a function defined in there that needs to point to that original namespace. Okay? All right. We might want to do something before or after the function. So in this case, we want to log. So we're going to do some logging here. So the log decorator is going to take a function. It's going to define a wrapper that takes 2 parameters. It's going to print A, print B, then it's going to call the original function, or it's going to say the result is equal to the original function with A and B passed in, and then it's going to print the result, and then it's going to return the result. And this is the function that the decorator is going to return. So we're going to return that wrapper. And we use it as so. Return A plus B. Okay. And so when we call add, let's say we called it with 3 and 7. Let's see what this is going to do. So first, we've already called log once. Okay. So we have fn is that add function we defined below. So fn is this add function here. And then we have a wrapper equals this new function that we just created. Okay. And then when we actually call that wrapper, because that's the return value, so add is set to this wrapper, then we create a new namespace. A is set to 3, B is set to 7, and it's going to reserve a spot for result because it sees that there's a result assigned statement there. Let's move this over to the side. Okay. Okay. Print A, so it's going to print 3. Print B, it's going to print 7. Result equals fn A plus B. So it's going to call the original function, the add function. A plus B, 3 plus 7 is 10. So result is now 10. Print the result, it's going to print 10. And then return that result. And so the return value of this is going to be 10. That is how that log function is going to work. So this allows us to plug in behavior, arbitrary behavior before and after the function is called. And this is actually a pretty typical use case for decorators. We'll go into a number of cases why that is when we talk about databases and various things like that. So moving on, the last case is we might want to modify the return value. Okay, so this is a function called def round result. It's a decorator. And it's a decorator, so it accepts a function. And what we're going to do is we define a wrapper. That wrapper is going to take 2 parameters. Okay. We are going to return the rounded result of the original function called with the 2 parameters. Okay. And then we're going to return that wrapper. So we use it like this. We say at round result def add A comma B, return A plus B. And if we call it, let's say we do 3.7 and 1.2, 3.7 plus 1.2 is 4.9, so this is going to round up to 5.0, right? Let's walk through one more time how this is called. So when we called the decorator originally, we're going to have the fn set to that add function, right? Then we're going to define a new wrapper, and we're going to return that. So the actual add function here is pointing to this wrapper, not to this add function here. So add calls the wrapper. So when we call add, new namespace. So we're going to have A is 3.7, B is 1.2. All right. Then we're going to call fn on A plus B. So the fn of A plus B is going to give 3.9. Then we're going to pass that into the round function and return the result, which is going to be 5.0. 3.7 plus 1.2 is 4.9, not 3.9. That's how that works. Now you might say, what if we want to round to arbitrary digits? Okay, put on your seatbelts. We're going to have some fun here. So we are going to define a function that generates a decorator. So we are going to have, let's say, places. Okay, and so this is going to create a decorator that it's going to accept a function. So let's define the decorator here, OR. And this decorator is going to return a wrapper that accepts two parameters, A, B. And this wrapper is going to return the rounded result, calling the function with A and B, and then passing in the number of places. Okay, and the decorator is going to return the wrapper, and the decorator creator is going to return the decorator. Okay, looks terribly confusing, doesn't it? You have to walk through. Every time I look at code like this, I have to walk through it step by step to understand what's happening. So we're going to say round result, and we got to pass in the places. So let's say 2 decimal places, and then we're going to call def add A comma B return A plus B. Okay, and when we call this, let's say we call it with 3.125 and 4.219, right? Let's walk through what's happening with this code. So when we call round result 2, we're creating a new namespace. Places is equal to 2, and it leaves a spot for decorator. And it assigns that to the function, right? It doesn't actually call this function, it's just creating this function. So we've run this decorator, and now we're returning this decorator. So round result 2 gives you the decorator, and now the decorator is called with the function add. So now we're calling this that add function that we've defined there. So now we're calling the decorator with the function. And this creates a wrapper equals some new function, right? And returns that wrapper. And because that wrapper was defined here, we're keeping these namespaces around. And so when we call add, we're actually calling the wrapper with yet a new namespace. So A is equal to 3.125. B is equal to 4.219. Okay, let's look at what it does. Well, it says round the function. So 3.125 plus 4.219 is returned, and then it's going to call it with places. So round that number to that many places. The places is 2. We're calling the function here, and the parameters are passed in there, and that should work. All right, that is a brief overview of decorators. The last thing I want you to try is do something insane, like go like this. Go at log at rounds result. Let's say 2, okay, at remember, and let's do at green, and let's define our add function there. All right, you'll note that if you do add.green, this will give you an exception. It's going to say attribute error. Okay, I'm not going to tell you why. You'll also know that when you do last fn with, let's say, 3.14159 and 2.71787, right, you will not get around it. You'll have to figure out why. But you will see when you call add with those same parameters up there, 3.14159, 2.7187, 2.71787, you will see 3.14159, 2.71787, 5.86, and the return value will be 5.86. Okay? So it's up to you to figure out what in the world is going on and why. You get to debug this code. If you have ideas on what is going, please leave your comments below. We'll talk about this code. If you can understand what's truly happening here, then you truly understand decorators and you know what's really going on. And you don't need to be scared of decorators ever again. And I'm going to give some homework assignment here. How much time do I have? I have just a few minutes. So let's challenge you to write some functions and decorators. So problem 1, write a function that accepts a single number and returns a function that also accepts a single number and returns the sum of two numbers. Okay, basically you want to write the function adder such that when you call it like this, you will get 8. So write that adder function. So the adder is going to take a number and then return a function that when you pass in another number, it's going to add those two numbers together. So that's problem number 1, write an adder. Okay. Problem number 2 is you want to write the function called partial that will accept a function like add, which just takes 2 parameters. And when you call it this way, it will give you 4. Okay. This is an interesting problem to do. Number 3, this one's pretty complicated. Let me show you how the code works. So we're going to have a summator. That's the result of a function you're going to write called make summator. And then when you call summator with 1, that's going to give you 1. And then if you call it with another number, like let's say 2, it's going to add the previous result 1 plus 2 and give you 3. And then when you call it again, let's say with 5, it's going to take 3 plus 5 and give you 8. Okay, that should be an interesting challenge. And finally, the last one is I want you to write a decorator called cache. And the way it works is you write C-A-C-H-E on the decorator, and then you write your function def add a comma b. And what it does is when you first call add, let's say you call it with 3 and 5, this will give you 8. And then if you call add again, it does not actually call this function. It just remembers the previous result. So if you call add with 1 and 2, it's going to give you 8. If you call it with add 2 and 1, it's going to give you 8. Okay. This will be an interesting function to write. This is actually the precursor to another decorator we typically use to cache results. Like we want to, instead of calling the function, we do something else, which is looking up the result of the function in a table or something like that. Hey guys, I hope you enjoyed this video. It was fairly deep. Hopefully now you start feeling like you have some power. And if you have any questions, please ask below. I'd love to explain these things. Take care and bye-bye. This video is part of a series on the theory of Python. You can click on the left to see the playlist and on the right to support my channel. Thank you very much for your time.